It's wonderful to see you all here, seeing some old friends that I've known for a very long time, seeing some new friends that I've met over the last few days and evenings. I've been doing presentations all week in Sydney. It's been 13 years since I last worked in Sydney as a tester, and I do always enjoy coming back to Sydney. So please do come and talk to me afterwards. I'd love to meet you all. Now, I do love a crowd that is a bit of a ruckus, so please do feel free. Yeah, there we go. So please do feel free to ask many questions, heckle if you will, or just ooh, as you see amazing things happen today. I will be doing a live demo with live coding, so I have prayed and begged and pleaded. So hopefully that sacrifice was enough. I am David McGregor. Now I did have a look, and I think I've actually got the longest job title of all of the speakers today, which is horrible because I don't really like long job titles, and we all know it's not about the length of your title; it's how you use it. So that really didn't go down well. I love coding. I love tech. I've been a tester for a very long time. I work for Planet. We're a testing consultancy. We are hiring if you are looking. So please do feel free to meet Mark, our recruiter, at our desk. But we have some nice T-shirts and some swag for you. And I think we've got a great Lego prize for the postcard game. So do make sure you stop by the booth and say hello to all of our Planet people. You can find me on LinkedIn. There's QR codes and all of that if you need. All right, so I'm going to share a little bit of a case study today. It's something that I came across, or it came across to me, and I'll share the story first, and there's a little diagram there that will hopefully give you a little bit of context. So we worked with a health insurance provider, and they were doing performance testing, and most health insurance providers will split a claim into two, so they'll pay part of it, and then the other part will go to Medicare, and Medicare will pay the rest. And when you're doing performance testing of systems, there are claims that have to go into Medicare's system. Now, Medicare being a wonderful, wonderful government organisation, they don't let you run performance tests against their test environments. So any sort of load, they'll just disconnect you, and you'll get emails and never be able to test using their systems again. So this was where this story starts today. I had some colleagues come to me and say, Dave, we've got to do some performance testing. We can't test against this Medicare API, and we need some help just trying to mock it out. And so that's exactly where we start today. So typically, we get some claims, Medicare claims that go in. I think I have a laser pointer. Ooh. Medicare claims go in, and then the process, while that claim is being processed, the health insurance provider will poll Medicare for updates. Is my claim processed? Is it ready? Is it complete? And it'll just continuously poll and poll and poll until it gets a response back from them saying that the claim is complete. So pretty important, because obviously if there are hundreds of claims that are outstanding, the health insurance provider is just going to keep polling for all of those hundreds of claims and want to get a response. So a little bit of nasty Jason here for those of you who are interested, but don't worry too much about it if you're not. But effectively, there's a couple of I guess API calls that we've got to mock. So that's kind of the introduction to the story, and in reality, talking about end-to-end testing by mocking out virtual services, it's not new. It's been around for a long time. We've all been there. There are many products. Most of the product vendors here will have some sort of tools around it. But there are many open source tools that do it as well. Your Mountebanks and all of those. But my experience here was a moment in time where I had the chance to just do something that was really interesting and really fun. And that's what I wanted to share with you today. And so we're going to go down that journey, and I'm going to show you how we went about doing that. So the problems that I had looking at the scenario that I had earlier was that it had to do with performance testing. And so immediately that causes an issue because there's a bit of load. So we had to have a solution that could handle that load. It could handle the hundreds, possibly even thousands of requests per second. Being a health insurance provider and being a consulting company, cost is always a factor. They wanted it now and they wanted it for nothing. Again, time, so they wanted it now. It needed to happen because it was holding our performance testers back. And finally, the requirement that came out of this was a requirement for our those mocks to record state. So as I mentioned before, it would go and create a claim in Medicare, and then it would poll and it would ask for a response. And so when that endpoint when it asked for a response, it needed to know whether it was in a processing state or a completed state. And you can never have, or you shouldn't ever really have a completed state come before a processing state. And so we had to maintain some sort of state or have some sort of order in how we were able to provide the responses. And so that's really the four corners of the two conjoined triangles of success here that I've put through. And it really means that it restricted the number of options that we had to provide that solution. So that was then a bit of a moment in time where we had this chance to look through and try to find some solutions for that. So I'm going to take you through a little bit of a demo and walk you through how we solved this using Azure API management. Like I said before, this solution could have easily been implemented in some of the other tools, a Mountebank, a Ready API. Any one of those tools would probably have done this really well. But generally speaking, they would have involved having servers spun up, VMs spun up, Docker containers, all of those types of things. And we really didn't have the time or the money to be able to spend that. So we did know that our client was using Azure. So I had a look and I thought, well, I know that you can do kind of mocked responses in API management, so let's have a look at that and see where we go. So we're going to look at doing two things today. One is we're going to mock the create claim endpoint, so have the ability for our fake performance testing insurance company to be able to inject claims into Medicare. It should check for a header, and it should return either a success or a fail if that header is there or not. And secondly, we need to get that status report back. So as the system polls, it's going to supply a list of transaction IDs, and it needs to return either a status of processing or complete. So if Medicare is still processing that response, it'll just sit there and process and process and process and eventually become marked as complete. When it's complete, we won't ask for that transaction ID again because we'll record it on our system and never call it again. And generally, we want to simulate some sort of delay in process so that because it's a performance test, we need to generate some sort of backlog in the originating system. So only 10% of the requested transactions will be completed at any given time. This is all going to make sense in a little bit, but I just wanted to set some rules before we go. And there was also a bunch of transaction IDs that should never return completed. So the client had said, yep, here's a list of 100 transaction IDs. They always need to be, they're our test IDs, and if we end up marking them as completed in our system, we'll never be able to set them as completed again. So there was a little bit of a restriction there. All right, so let's get into all of this. Now, how many of you are familiar with Azure's API management gateway? No? Any boos? Just no? Yeah, boo. Yeah. All right. So I'll show it to you, and we'll have a bit of a look. All right. Testing talks. So I have created this, and I should be connected to the internet. Let's have a look and see. So effectively, the API management tool it's just an API gateway. It exposes an endpoint. You expose, paths and methods, and users can hit that endpoint, and it just routes calls to different endpoints. So you can say, well, I want my GET requests to get claims going here, and I want my POST requests to go to this other service, and it's like traffic management for APIs. And really, this is classic Azure. It looks, yeah. If you've ever seen Azure, this is what it looks like. You can define APIs, and so we're going to do that. Let's define the endpoint for our for the make a claim endpoint. So we're going to create an API, and I'm going to call it my Medicare mock, Medicare mock, and we'll go and create that. And it's going to go and create it. So we can create all this, and I'll show you the first one in the user interface, and the rest of it we'll do in code, because doing everything as code is better. And I'll close this so that we get a bit more real estate here. And you can see now that I've got some APIs, or I've got an API, and I can start to add some operations. And so let's do a post, and we're going to post to the make a claim. So we'll call it the make claim endpoint. And you can see that it's already starting to give us some options. So we're going to post because we want to create a resource, and also make claim as the endpoint. And what I can do here is I can add some requests. So there's going to be a little bit of a payload. We're going to give it a list of transaction IDs. And so I can, if I copy this here, let's add the operation. So we want it to provide a response, and it'll be a 200. Okay. And we'll give it a hello world response, and we'll hit save. And so now it's going to go and it's going to expose these endpoints, and we'll have something that we can actually call. So I can hit test. This is the moment of truth. Hit send, and we get an internal server error. All right, let's try that again. I know. So what I didn't do was I didn't actually tell it what to do. I created an endpoint, but I didn't actually instruct Azure to do anything with it. So you can see here it's kind of passing it through to the back end, and there's no endpoints there. And so hence it kind of fell over. So we're going to add a policy, and we're going to say I want a mock response, and we'll mock it with a 200 response. We'll save that. And fingers crossed, let's see how we go. There we go. We got our 200 response, and we're all good. So now we have an endpoint. We have an API that's returning. I can go and create claims, and I'll get a 200 response. Now what I can do is I can actually go in, and now we're going to create the next endpoint. We're going to create a post for a status. So we want to then give it transaction IDs and get some status back. So let's do that. While I'm here, I'm going to update this. And you can define requests. You can define all sorts of data that is required, that needs to go in. But really, because it's a mock, we'll accept everything. At the moment, we'll just say whatever you give us, we're just going to return a 200 because that's all we need. So let's go into Visual Studio Code, and let's have a look now and see what we can do. I'll make this a bit bigger. I've refreshed, and hopefully we will see the API that we just created. There's our Medicare mock, and we should see some operations here. All right, so there's our make a claim endpoint. And now that I'm in Visual Studio Code, we're starting to look at everything as code. I can now see exactly some of the details that I've just entered in, that the UI hides. But more importantly, I can actually see that policy that the make a claim endpoint should be calling. And we should see here in the overarching policy, there's my mock response where I say, yep, I just want to return a 200 when I get a call. So let me move that out of here. Is it too small? I can make that a bit bigger. Is that easier? All right. You're welcome to come to the front as well. I won't bite much. All right. So let's put that over here. When my mouse actually works. Mock response. So this is where the client kind of started. They said, well, we've got APIM, we know we can do mock responses, and that's really good, but it's not really flexible enough because as you can see here, you can really only give it a status code. And so what I started to do was to go, well, I'm pretty sure that you know, Azure's been a bit clever, and they've given us the ability to actually do some more interesting things. So let's have a look in the documentation and see what we get. And there's actually a whole bunch of different policies. When they say policy, different operations that you can kind of instruct it to do. And so one of these things, and you can see here that there's a whole lot of different policies that you can do. And one of them is interesting. So if you remember back then when I was talking about the two endpoints, one of the requirements was we needed a header. And so what we can actually do is we can actually call this check HTTP header policy now, and then we can say, okay, well, if that header doesn't exist, then return an error. So let's do that. If I look in here, we can see that there's some code that I can put in, and we can check the header. And if I go back in here, we can paste it in, and we should be all good to go. If I now paste that in. Let's do a check header. So now I can say, well, if this header, and we'll call the header maybe a correlation ID or something like that. Apologies for the typing. If I don't get that, please return a 400 error. And return a message, which might be, you know, please enter correlation ID, and so forth. So what this does is now I can start to validate in my performance tests. I can validate some of those incorrect scenarios. So I can start sending invalid data alongside valid data, and just make sure that the system can handle with, you know, various errors that get returned back from that fake Medicare service. So we can do some positive, we can do some negative testing as well, and it's fairly easy to go and put it in here. We don't need this value in here because we're just doing the check header. And so now if we call this, I think I can upload it. There we go, it's updated successfully, and we should be able to go in and test it and see. I'll make this a bit bigger as well. Apologies for the small text there. And if I send it, we got a 200 error. So let's try that again. Make claim. I'll make sure that it's okay. Check header correlation ID. We'll try that again. Maybe it is adding the header. No? The joys of live demos. All right, we'll move on. And so you'll remember that the requirement was to be able to return some code that actually had an interesting state. So we needed to be able to return 10% of the time a completed response and 90% of the time a processing response. And so what we're going to do here is I'm going to actually go and create a new set of APIs. And I'm going to import it from an open API file because, hey, it looks like the Medicare have published their endpoint. And so I'm going to import an open API file, and we'll call this the second mock. Oops, typos there. And what it's going to do is it's going to take an open API file and it's going to kind of set everything up for me, which is really nice because it means that if you have a service that publishes an open API spec, you can just import it in and it'll work straight off the bat. And then we just fill in what we need it to respond with and we can go from there. So it'll take a moment to create, but it ultimately should get there in the end. There we go. There we go. So we now have our Medicare, our second mock, and you'll see that we have our two endpoints. So we have our medical claim and our status endpoint. And so these match what was in the spec. It comes with some. It won't have a policy, but it'll come with the sample, I guess, formats that it is expecting. So if I scroll down, we can see here that it's now picked up from the OpenAPI file what should the sample content that it's expecting, and so we can work with that and we can kind of tell it to respond to that. So let's look at this status policy, and we should be able to go in here, and we can now start to say, okay, well, we want that status endpoint to return something. So, like I said before, that mocked response policy kind of we returned a response, but it was pretty static. So we actually want to return something that is a little bit more dynamic. And it turns out, after digging through the documentation, that you can execute code in this. You can execute C# code. And that's really great, because suddenly that means you've got this really flexible way of responding and handling information. So we can actually call what would be a return response. And we'll say, let's do 200. And for the moment, we'll make sure everything's working. Hello world from testing talks. So let's upload that and make sure that Yep, excellent, thank you. There we go. So you can see that it returned, when we do this as code, we get code completion. It returns some meaningful errors as we go through. So you can see it's performing validation on the file. So you get quite a lot of benefits from doing this way. It does the same in the UI as well, as you're coding in the UI. So let's go in here. If I refresh this, it should now have our updated mocks. There's our second mock. And here's our status. And if I get rid of this, we can see that our return response policy has been set. And so we're going to try and test it and see if this works for us now. And there we go. So we're seeing our response. So that's obviously a very static response. We now need to add some code in to be able to get it to return what we want it to return. And so let's do that. What we can do here is we can, let's get rid of this. And there is this little special curly bracket thing, return. Now it's going to start executing code, and it's C# code, and we get access to a subset of .NET's classes. So we can have things like lists, dictionaries, arrays, all of those things, just a basic subset of .NET methods and types. So let's return just a simple string and see if that works. So make sure we're executing code. And we'll go back and hit send again. Wait for it to... There we go. So we're now returning hi. So we're executing code. So that's a great start. So now we can go and start to add in some of that functionality and some of what we need this API to do. So because I know that we don't have too much time, here is some that I prepared earlier. And so let's just start by returning. Let's just start by returning some JSON. So all we want to do is we're going to say, I want to return status complete, because that's kind of the first bit of information that we need. So we'll upload that, wait for that to go. And we'll go in and we'll test it. It takes, takes a few seconds to propagate, but eventually, there we go. So we've got JSON now. So we're starting to look like we're in a good place. And this is nice because I can kind of iteratively develop this and work on it. So I'm going to grab some more code, and we will go to, let's add a transaction. Because remember, we're going to send in a list of transaction IDs. So let's go and replace that. So what we're going to do now is we're effectively going to start to create that transaction response, so that list of transactions that we need to be returning. So all I'm going to do is I'm going to add a transaction to the object, and we'll see how we go from that. There we go. So now we have transaction status. We have a processing status for a single transaction, and then an overarching status, which is complete. So that status complete means that we've returned a response successfully, and then each individual transaction or each individual claim can have its own status. So that's really good. Let's keep going on. As you can see, there's a whole bunch of stuff we can do here. What we need to do is we need to actually return a status for each transaction ID that was entered in. So let's do that now, and I'm going to paste the code in. I would like to type this all in, but it's these days PowerPoint is much more my tool of choice, tool of forced choice. So my typing is fairly slow. So I'll copy and paste so you don't have to watch me type and retype. But effectively what we're doing is here we can now say, well, I want to get the list of transactions from the request. So I'm going to give it a list of transactions. And for each of those transaction IDs, hopefully you can see this code, it's not too hard to read, but for each item in request, we're going to create a JSON object, and we're going to add it to that array, and then we'll return it. And for this purpose, we're just going to return processing for everything. So we'll try that again. And this is great because this is now, we're just iterating, we're starting to build on this. And we can see now that we've got a couple, as I've fed into the request, I've given it a transaction ID with 2 transactions, and we're now getting 2 transactions back. And if I add a third one right here, and hit send, we should get a third transaction back. Right, so there's our testing talks transaction. So now we have a dynamic response. So that's really great. So now we've kind of covered what most of the service virtualization and mocking tools do, right? We can return dynamic responses based on what we've sent in. But we want to add a little bit more logic now to make sure that it can return the correct ratio of completed responses. And so, again, we're going to go back to my trusty code here, and I'm going to copy that. And I'll walk you through it. Do feel free to ask any questions if you wish. Okay. So what are we doing now? So what I've done is I've just added a random number. We'll generate a random number. If that random number is greater than 90, so 90%, then return, so that if it's greater than 90, meaning 10%, we return completed. If it's less than 90, so that's the remaining 90%, let's return processed. And we can add that to the array, and now we should hopefully have an endpoint that's returning a nice spread of completed and processed according to what the client was wanting. So let's upload that. Here we go. We'll upload that. And we'll give it a test. And we can see one of them is now been marked as completed. If I run it again, a different one's been marked as completed. So we can see that random number generator is now giving us the ability to mark different transaction IDs as being completed. So that's really great. So now we've actually been able to satisfy one of those key requirements that they needed for the performance test. And so What we'll do is in the last bit of code that I've got here, I'm going to add a few extra fields and we're going to round it out. And we're going to do the final version of this code here, and I'll walk you through it. So, obviously just the response from Medicare has a bit of extra data in there. It has transaction IDs, it has associate names, references, request transmission types, lodgement date and times. So we can actually now generate, I guess, a random date anywhere between now and 72 hours in the future or the past. So in this case, in the past, to indicate, hey, we've had this, it's been processing for X number of hours. So we can start adding other dynamic forms of data. And what I've done as well is I've added a list of those IDs that we never ever want to mark as completed. So again, remember that client said, this is the list of IDs, do not ever mark them as completed because you will start messing up our test data. And so all we do is we check, is the transaction ID that we're interested in that list? If not, or if it is, always return processing. Otherwise, we go through that piece of code before where we do the split of 10 and 90%. So let's run that again and see where we land. And there we go. So we're still working. Now I think if I add an ABC123 up here, that's one of the ones that was should never ever return completed. We can start to see, there we go, we've now got our kind of each transaction has all of the extra data. We're generating lodgement date and time, that's fairly dynamic, anywhere between now and 72 hours in the past. And we can see that we should have, none of them were completed, so let's run that again. There we go, so we've got that one was completed, that one was completed, ABC123, that one should never ever be completed. So let's try that. Let's just make sure that, let's say, okay, well, everything should be completed. We'll run a test. And we should have just that one continuously coming up as, we'll give it a time to update itself. There we go. So we've got reported, complete, 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 and this last one is still in processing. So it looks like we've actually been able to kind of iterate through and meet all the requirements of what we needed to do. And the nice thing here is that because we've been able to set this up, and it's been quite quick. Obviously, I've run through it in the short number of minutes that I've had. But in real life, this took about 2.5 hours, 3 hours to kind of get up and running all up, which when you're working for paying clients is quite an impressive feat. We didn't have to spin up Docker containers. We didn't have to run a VM. We didn't have to worry about traffic and load, and I'll show you that now. Because the nice thing is that if you look at the pricing for API management, what you get is you effectively get the first 1 million operations included for free, which is great because for a lot of clients you can say, yeah, we'll spin that up and it'll cost you absolutely nothing other than just a couple of hours of our time. And that's really great. What you can do then is when you need to scale, and this was for a performance test, so we knew we needed to scale, is that you can bump up to different levels, and down here you can see the estimated maximum throughput. So particularly when you're running a performance test, if I needed to run, let's say, 2,500 requests per second. Now, 2,500 requests per second, as an example of how much volume that is. So that is at lunchtime on a Monday morning, the maximum, or it was back then, that was how many requests Seek was getting for viewing job ads, right? So think about how many people would be looking for jobs at any given time. It was around that 2,000 requests per second mark. So, I mean, that's a lot of traffic. And the wonderful thing is that it's $1.50 an hour, $1.43, add some GST on that and you get $1.50. I mean, that's not going to break the bank. You can, yeah, And you're not having to spin up any containers, any VMs. So it's actually quite flexible. Now, there will be cases where you absolutely need to have a different solution. And that's totally fair. This was a really kind of, it was a fun exercise for me to do. It was really great. It kind of hit all of those spots of, oh, I could just do this quickly. It's really easy to do. The code is not that hard. You get all this code completion as well. And it's really, really, really great. So, yeah, I just wanted to share with you that just that fun that I got to have. So, so it was cheap, it was fast, scalable, and we could return dynamic responses. It checked all the boxes for the client. They were super happy. So happy, in fact, that they came back to us and said, we want more. And that was the point where we thought, okay, well, tell us what you want. And it turns out that they wanted full control over response processing times. They basically wanted to be Medicare. And so this worked for the first performance test. The next performance test, we went and we were able to do some more work with them. Once you get past that kind of faking responses, then you need to actually store state. So we're going to store your transaction ID and we're going to give you the ability to update it. We start to need to get into serverless functions. So version 2 of this was using a serverless function behind APIM. And it ended up looking like this. By the way, if you're not doing diagrams as code, this is generated by code. You should definitely start doing it. So what we ended up having was there's our claim endpoint. It stored everything in a database, and there's our status endpoint, which the claim processing was able to call in. But we ended up creating another endpoint, which just let JUnit update transactions. So we could mark transactions and say, yep, you should now be processing, you should now be complete. And so that gave us the flexibility to be able to completely control that whole Medicare environment in a performance test. So it's really great, really, really easy to do. I got one of our grads to do this endpoint in Azure, and it took them about 2 days to get it up and running, including learning and Googling and all that kind of stuff. So not too bad. So in reality, there are lots of ways to mock. There are lots of ways to stub data, to do virtualized services. It's not new. It's been around for a very long time. But this was a really fun way, and to do it, I wanted to share it with you. It's cheap. You can all go and you can set up a trial account with Azure. You can try it out and play with it, and I really encourage you to do it. And ultimately, it's a great solution because, especially if you do it as infrastructure as code, it's something that can be spun up and torn down straight away. So yeah, very, very, very flexible solution. It was a real pleasure to be able to share that with you today. Any questions?
Yes, I have a question.
All right. Cam, you may as well come up, but yeah.
So you use this as a use case for performance testing.
Yes.
What other use cases you can use this for?
Thanks, team.
We'll do a round of applause after the questions.
All right, so other use cases for this. So you can use it in functional testing. So we have sample websites, and I've created mocks for that sample website here. Again, you can suck in an open API definition and create functional tests that way. If you have functional tests where you need to return or simulate user error or 400 errors or 500 errors, you can do all of that as well.
Can we push in data, say for example, having a system that is not there built yet, but pushing in data pretending to be that system?
Yeah. So once you go down that serverless route, you can create whatever databases and data sources you want. You can connect it up to Redis as a cache and do all of that as well. It's very, very flexible. And again, the Lambda side of it, the serverless function, your first million requests are free. So it's a bonus. All right.
So over to your question.
Excellent. Thank you. Thanks, everyone.